Hey everyone, my name is Aman. I'm a product manager at Arize AI. I'm joined by Erica and Ronnie from Weaviate and Unstructured. Erica, would you like to introduce yourself?
Yeah, hi everyone, I'm Erica Cardenas. I'm a developer advocate at Weaviate, the open source vector database, and I'm so excited to be here along with Aman and Ronnie today to talk about the ultimate RAG stack. Ronnie?
Yeah, thanks, Aman and Erika. Nice to meet you today. Hi, everyone. I'm Ronnie Hoseda. I'm DevRel engineer at Unstructured.io. I help connect with developers and work with partners to convert unstructured data into structured data for LLM consumptions. Nice to be here.
Awesome. I'm going to go ahead and share my screen. Great. And today we're going to be talking about optimizing RAG with LLMs. We're going to be talking about various chunking techniques using unstructured, re-ranking, using some of the tools built into Weaviate, and basically show how you can evaluate these types of systems when it comes to sort of, actually being able to deploy in production and evaluating those systems offline as well using Arize and our open source tool, Phoenix. So what's the agenda? We're actually going to be covering a little bit of an intro into unstructured, what the tool is, why you should use it, as well as sort of an intro into vector databases as a whole. We'll kind of have a deep dive into Weaviate and how it works and what sets it apart. And then we'll get a little bit into the overview of sort of search and retrieval as a problem space. What are some of the things that can go wrong? And then actually jump into a live sort of workshop and demo using a real-time sort of LLM query engine for evaluation. Cool. And I'll hand it off to Ronnie for an intro to unstructured.
Sure. Thanks, Aman. So yeah, next slide, please. Yeah, so companies strive to leverage advanced analytics and AI in today's data-driven world. However, according to McKinsey Consulting, many organizations found 60 to 80% of machine learning engineers and data scientist times is spent ingesting and preparing data. As a result, the transformative powers of LLMs remains underutilized due to hallucinations and a lack of quality data to ground the LLMs. To tackle these problems, Unstructured has built our platforms from the ground up based on two components, connectors and transformations engine. First, let's look into our components, connectors. Our modular connectors automatically map data types and schemas, making integration with our transformation engines easier. The built-in connectors ensure our reliable data flows and can also handle data loads efficiently. It will adjust automatically to meet demand. The second component is the transformations engine. Most document understanding models are fragile when faced with complex layouts, tables, and file formats such as PDF, PowerPoint slides, and HTML pages. They often require complex ETL processing and tools, and these solutions are computationally inefficient and work only with limited file types. The unstructured transformation engines can ingest almost any files with natural language data, reducing the needs for complex configurations. We have invested in optimizing model architectures and employing model-based and rule-based solutions such as NLP and transformer models. It will decrease computational costs and making the engines run efficiently on GPU and CPUs. Once you have provided the files from different sources, unstructured tools will do the heavy liftings under the hood. You can define configurations to optimize the outputs, which is JSON by document elements. From there, you can generate embeddings using any LLMs and store the data in various databases. Thanks. Moving on to the next slide. So there are three ways to use unstructured technology. First, if you are prototyping and developing ETL pipelines for your unstructured data, you can use our open source library on GitHub. Scan the QR codes on this slide to link to our GitHub repo. Second, if you are a front-end or apps developers or want to experiment with our technology without the hassle of installing the dependencies, you can use our hosted API. You can request the API key from our website. You can also build your own API from Unstructured API repository. Finally, we are building up platforms with all the support for the enterprise users. That's it. Thanks.
Awesome. So now I'll give an intro to Weaviate. Next slide, please. Thank you. All right, so Weaviate is an open source vector database. And if you all aren't maybe familiar with what a vector database is, it is a database that stores unstructured data, whether that be text, images, audio, etc., and it stores it as vectors. So you take those vector embeddings and you store it in an index where it's an easy way to take the distance from the query vector to the objects in your database, and then calculate the distance to see which top document is the most relevant. So for example, the embedding of a dog is closer to the term wolf and further away from the banana vector. And obviously one is an animal and then one is a fruit, so it won't be in the same vector space. So once you've vectorized your data, it is then stored in a high dimensional graph, which we have here on the right-hand side. So for example, when we search for kitten, the nearest neighbor cat will be retrieved, even though we don't have the keyword kitten in our database. And this is really what distinguishes a vector database from a traditional database. In traditional databases, objects are retrieved by exact keyword matching, whereas in vector databases like Weaviate, objects are retrieved by the semantic similarity. And I hope you're able to see that visualization with the graph on the right-hand side. Next slide, please. All right, so with that in mind, let's jump into how exactly it works. So vector databases use approximate nearest neighbor algorithms to index and store vector embeddings. Since the objects are represented by numbers, we can easily calculate the distance from a query, so kitten, to the objects in your database, so cat. Instead of comparing the vectors one by using a brute force method, the ANN algorithm may not return the true K, which will have a trade-off with accuracy, but in return, it gives you a huge gain in speed. So Weaviate has a custom implementation of HNSW written in Go. And then also on the right-hand side, we have a visualization of what an HNSW graph looks like. So it's a multi-layered graph, and it navigates through the layers to find the nearest neighbor in a scalable manner. So the graph consists of multiple layers. We have on the top layer 2, layer 1, layer 0. And the bottom layer has all of the data points, while the top layer has the fewest data points and is the entry point. So the blue dot is the query, and the task is to find the nearest neighbor in the graph. Nodes are only considered if they have an edge to a node that has been explored. So as we take that blue node on layer 2, and then we work our way down, we'll end up at the pink circle, which will be the document or image that is retrieved. Next slide, please. So product quantization compresses the vector by representing them with the centroid point on each grid. With HNSW and PQ combined, this results in you needing less memory, which makes it more cost effective. And we released this in a new release, so it's a new feature and it delivers an immense amount of value. Next slide. All right, so with all the attention around retrieval augmented generation, vector databases are an important component to that stack. As we see in this workshop, Weaviate is used to store the data from unstructured and then orchestrates the vectorization from OpenAI to grab the embedding, so it vectorizes your data, and then we'll be using the Cohere Reranking model to improve your search results. And then, in addition to handling the inference, you can search and generate responses directly in Weaviate using the GraphQL API or client programming languages, whether that be Python, TypeScript, Java, or others. So here's a typical RAG flow, which is the point of this workshop, and I'm really excited to dive into the code so we can actually all get our hands dirty and begin coding together. But in Weaviate, we have the generative module. So this takes the most relevant documents to your query and passes it to the large language model to generate a response. So this is done in 2 steps. The first step is to take the query and find the most relevant documents. And then in step 2, we take those documents, pass it to the LLM to generate a response, and then it will output the response and based on the prompt and documents that it was given. Next slide. Thank you. All right, so Weaviate has a modularized ecosystem, which allows you to seamlessly use various integrations to improve search results. So maybe you already have your vectors, so you're not interested in using OpenAI or Cohere. You can just bring in your vectors and store it in your Weaviate instance. And then you can also perform different search methods. So we have pure vector search, we also have BM25, and then we have hybrid search, which uses a combination of vector and keyword matching. And this just depends on the alpha parameter. And in the notebook, I share an example of how to do this. And then lastly, to enhance your results, you can use our question and answering module, also our generative search, which I shared on the previous slide. And then you can also use re-ranking, which we'll see in this workshop. So I'll now pass it over to Aman to talk about search and retrieval.
Awesome. Thanks, Erica. And you did get one question, actually, which I think you answered, which is just to ask you the question, does it support product quantization and search using GPUs?
Yeah, so in our latest release, we do have HNSW and PQ combined together.
Awesome. Super cool. Thanks for the question.
Yeah, thank you.
Great. Cool. So I'm just going to give a really brief high-level overview of what search and retrieval is as a problem space. So first off, why do you need search and retrieval? So I mean, on the left-hand side here, we're basically, imagine you're interacting with ChatGPT. If you ask, a question that is past the cutoff date from ChatGPT, for instance, if I say, tell me about Arize. So I mean, we're a few years old, but we weren't as part of the cutoff data set for that GPT 3.5 and 4 were trained on. So as far as GPT-4 knows, Arize isn't even part of the sort of parametric memory that the model was trained on top of. The way that you can kind of get around this limitation is by feeding documents and feeding information into the context of GPT or into the context of the LLM. So here, all I did was basically copy our sort of product docs homepage into the prompt that I then asked, and into the context window that I then asked the GPT based model to answer on top of. And you can get a much more specific, a much better answer just by providing this context into the context window of the LLM. So, what does RAG really get you? So it allows you to provide your own context and data to the LLM, ground responses and sort of trusted sources of information rather than relying on parametric memory, and then be able to easily swap out the documents from the knowledge base and the index. So how does the system work? Erica already basically covered this, but just to sort of recap, when a user query something like how much does Arize cost gets asked of the systems generally perform a sort of similarity lookup. So in Weaviate, there's a number of other modules you can swap in and out of, which we'll get into. But in sort of at a high level, a lookup is performed that finds the most similar document to the one that's being, to the one that represents the user query. And that individual chunk of the document is then retrieved and augmented in the prompt itself. So you might get something back like, user is asking, how much does Arize cost? Here's a relevant context. Can you answer? And then that all gets sent to the LLM to provide a response. And typically, when you look at this type of system, there's actually, ideally some type of user feedback that tells you, okay, did the LLM give a good response based on what the question the user was asking is? And you can see across the stack, there's a number of components here that kind of help you stitch together these various tools. So if you wanted to use Unstructured for something like ETL or Weaviate as your vector DB, Arize and Phoenix can kind of help across that whole set in terms of evaluating the response that you get back. Because the truth is that things can really go wrong in various parts of these systems. So let's say you don't collect user feedback. How would you evaluate this system? Maybe the model hallucinated. If you're using an agent, how would you get visibility into the performance of that agent? And then ultimately, what we're going to be focusing on today is sort of evaluating bad retrieval. How do you know if the documents that you've retrieved are actually relevant to the questions the user is asking? So some of the common problems that we see with retrieval-based systems is that when the context is actually retrieved for a question, let's say something like, do you support international calling? You might get back a piece of context that ultimately leads to a bad response. That could be because you don't have enough documents close enough in the vector space based on, something like what, based on your knowledge base that might be stored in Weaviate, that actually help you answer the question in the first place. Or maybe the document that's most similar in that vector space actually isn't the most relevant to the question the user is asking. So we're going to be diving into a sort of use case here of how to connect these tools together to build your own RAG application, and then actually evaluate all of those systems and components within a notebook as well. If you have any questions, just feel free to join the Arize community. We'll be in there answering questions on Slack. We have a fantastic team to kind of help support if you hit any bugs or snags along the way. And then we will be sharing out the notebook link as well. Great. So I'll actually hand it over to Ronnie to talk a little bit about how this chatbot architecture comes together. So just as a high level, if a user query is being asked, we actually will be talking about that embedding generation process, how the documents are chunked up, and then what actually happens underneath the hood to generate a response in the first place.
Sure, thanks, Iman. So I'm going to share my notebook. So yeah, very exciting today. I think there's a lot of learning objective we will learn today. So first, we're going to look into like ingesting and processing data using unstructured tools. This will include like a different chunking strategies that we will discuss later. And then the next one, store data sets into Weaviate's vector database. We're going to evaluate LLM assisted evaluations using Arize Phoenix, and then we will rank the results again in Weaviate. So because it's very long, we're going to divide into two notebooks here. So let's talk about the data sets first. So the data set is derived from Arize AI documentations from the websites. And we're going to use the data sets to build our knowledge base and run the queries. And then we're going to re-rank the result. So I'm going to cover like two topics here. Let's dive into the ingesting and pre-processing datasets with unstructured. So the first one, we can install unstructured library. And we're going to scrape the datasets directly from Arize websites. So the function accepts like two inputs from HTML files, text strings, and URLs. So using like the partition HTML by unstructured, it will provide a unique interface to process HTML documents and extract meaningful elements. This function is highly configurable with optional arguments. For example, you can determine whether to use SSL verifications in the HTTP request. You can include or ignore contents within headers and footers HTML text, or choose the encoding methods for the text inputs. So the basic usage is pretty simple. You import partition HTML from unstructured library, and with just one line of code, you can pass the URLs. So once we get the outputs from partition HTML, we can store the data sets into the JSON schema. So in these tutorials, like we're going to build a nested JSONs, like composing of two keys, which is the metadata and page contents. And within the metadata, we're going to have a nested keys, which is the URL source and the page titles. So if you look at the codes, like first, we're going to load like the URL links, and we put like into a Python list here. And then in the following code base, we're going to run the elements like through the partition HTML, pass it the URLs in as the parameters, and then the output is the elements. And using the elements here, we can structure the outputs into the JSON schema that we saw earlier. So once this is done, we can moving on, like saving all the data into JSON files. And this is the examples from the first web page that we extract from Arize web page right here. Moving on to the next topics is chunking the long websites. So when dealing with extensive websites, such as the glossary page, we often encounter text that are too lengthy for LLMs to process in a single pass. In general, we can use two chunking strategies. First is fixed size chunkings. While simple to implement, it can lose relevant context, especially when the important information is split between chunks. So the second strategy is the context-aware chunking. If we inspect the glossary page, we will see the terminology is embedded in the HTML heading tag and the descriptions in the span tag right here. So if we can group the HTML elements in a hierarchy by utilizing the element types identified by unstructured partition HTML. Context-aware chunking maintains the logical structures and coherence of the HTML content. So here's the high-level approach to implementing context-aware chunking using unstructured elements. First, use partition HTML to extract the HTML documents into unstructured element objects. And then the second one, we can iterate the element objects and group them together based on the hierarchical relationships. So this is the code to group them together. But as of yesterday, in the latest release, we have implemented a new functionality called chunk by titles. So with this new functionality, it will simplify your codes to group the elements in a hierarchical methods. So yeah, so now you have seen like the ingestions and also the chunking strategies. Moving on, I will hand it over to Erica to store it into Weaviate's vector database.
Thank you, Ronnie. I think we can only have one screen share at a time. Perfect. Thank you. How does that look? Should I zoom in a little bit more or?
Perfect.
Good. Okay, awesome. Do you mind if I answer a few questions that I saw come in, or is that?
Go for it.
Okay. So I think the first question, I think that's a joint one, is does RAG fall under prompt tuning technique? And I would say yes, you're prompting the language model with new information, right? And you're using that external context that maybe it wasn't trained on. So yes, that is considered RAG. Do we all agree? Yeah, go on.
Yeah, I think so. I've never heard that term before, actually, prompt tuning. It seems like a combination of prompt engineering and fine tuning. So very clever. And yeah, I think that iterating on prompts and prompt tuning, sure, that definitely consists of using RAG to augment the context.
Awesome.
Yeah.
Very good. And then there's actually another question about chunking and how, like, what is the most optimal way to increase the relevance? Because Ronnie, as you said, if you're scraping a full website, how should you chunk it up optimally? Like, is it by paragraph, maybe by sentence, which might be a little crazy, but you just covered that. So hopefully it added some clarity to that. But yeah, Ronnie, what do you think?
Yeah, so I think this is like where the vector database comes in play, because like once you chunk like your contents into like a different records and you put it into Weaviate, then you can do like a similarity search. So yeah, this is my answer. I think Erica can go deep dive into Weaviate vector database.
Oh yeah, awesome. All right, so jumping into the notebook now. Thank you for your questions. I'm sure we'll tackle them after the session. So once you have installed the dependencies and libraries, and then you run this, you'll need to start with passing in your OpenAI key. And then in addition to OpenAI, you will also need a Cohere key, and they offer a trial key, which is completely free, but the pitfall is that there is a rate limit. But for this workshop, we'll just be running a few queries, so it will be more than enough for this workshop. And I included a link where you can grab the Cohere key if you do not already have one. The next step is to fetch the data. So this is taking in the Arize documentation and then also the chunks as well, and just reading that JSON file. All right, so now jumping into the Weaviate part. So there are 4 ways that you can run Weaviate. You can use our WCS, which is a managed service, and this is great for development and in production. You can also run it locally by using Docker or Kubernetes. And then we also have Weaviate embedded, which is running directly in your runtime, which is great for this workshop because you don't have to sign up or register or have anything in the backend. You can just easily connect to your Weaviate instance, create it, upload your data, and then just start querying, which I think is great for these quick workshops. All right, so the first step, once you have set up your Weaviate instance, you'll need to create your schema. So just keep in mind, if you run the schema once, it will, and then you try to run it again, it will result in an error. So my best advice would be to use this delete class. So you're restarting your instance without any schema in place, and then you can just rerun it. So if you run into that problem, that is most likely the error that you are getting. All right, so first we are initializing our Weaviate embedded client by passing in our OpenAI and Cohere key. You might be slightly confused why we're using OpenAI and Cohere together, and I'll go over that. At a high level, OpenAI is for the embeddings, Cohere is for the reranking model. All right, so in order to create your schema, you're passing in your class name, which here we have Weaviate vector class, but this can be maybe blog post, documentation, and just anything depending on your data set. We need to specify the vectorizer. So for this workshop, we're using text-to-vec OpenAI. And then we also are, this is optional to include. There are a few defaults, but if you want to configure your HNSW implementation, then you would do this underneath vector index config. And then in addition to that, we'll need to specify that we want to use the Cohere Reranker module, and then also the model that we are using from Cohere. And we're just adding this at the class level. And in addition to having the class, we can also have properties. So you can have different data types, whether that be text, integers, date, the geo coordinates. There's like a various amount of data types that are in Weaviate. So it gives you the option to really take all of this unstructured data that you have and store it in a vector database. All right, so once you've created your schema, we'll now want to upload our data to our Weaviate instance. This might take a little bit to run. There might be a few reasons why that's happening. We are vectorizing our class again, but we are also storing our embedding. But then Weaviate also has a batch functionality where you can define how you want to batch upload to your Weaviate instance. All right, so once you've defined your schema and your data is uploaded, we can now query using Weaviate. So I'll be using the GraphQL API, but like I mentioned earlier, we do have other client programming languages like Python, TypeScript, Java that you can use to query your Weaviate instance. So I'll be covering 3 examples. The first one will be using pure vector search to find queries that are about how do I get an Arize API key, and that is just fetching the parts of the documentation that can answer my question. Okay, and then the second question is using hybrid search. So that's a mixture of BM25 and vector search, and I'm tuning how much I want to weigh each based on the alpha parameter. And then the third query is taking the same hybrid search query, but then adding reranking to it, and you'll see how well the results improve, how much the results improve. All right, so starting off with the first one, I am retrieving the Weaviate vector class. So that is the class that we defined in our schema. And I am running a near text, which is pure vector search on concepts about how do I get an Arize API key, limiting that to only 3 documents. So I don't want it to print out maybe all of the objects in my database. I just want it to print out 3 because maybe that's just all I need. And then from the documents, it's just going to output the text rather than the other properties that we have in our database. And then I'm just going to include the distance just to see how far away it is. So once I run this, the first answer is answering about, I don't know, the first answer is just saying how to access your API key. And as you can see, the results aren't great. So I think one way to solve this is by using hybrid search, because it's using BM25 for that keyword matching, where maybe it will pick up on what Arize is, what an API is, and then also the key. So let's run that first. Okay, so here is a hybrid search query with the alpha set to 0.75. And what this means is, well, I guess I should begin with what alpha is. Alpha is weighting BM25 or vector search. So an alpha of 0 is pure keyword, and an alpha of 1 is vector search. And the default is 0.5. So if you don't want to specify this, or you're happy with an equal weighting of both, then you can just completely leave that out. But I just set it to 0.75 to skew more towards the vector search. And then I'll just output 5 documents or chunks of data, and then I'll just output the text that I have. Okay, so as you can see, when I ask how do I get an Arize API key, it's just saying reach out to support for it, like in order to grab the API key. Maybe that's like not that great. So what I want to do now is re-rank the results and consider that query again. So again, I have my hybrid search query, limiting it to just 10 text chunks, and then I'm re-ranking it based on the same query, and then outputting the text and the score. And sorry, maybe I should have pre-printed it a little better, but essentially the first response, what it was doing was outputting how you can get an Arize API key by just clicking on the button on the website. And that fully answers the question of what we were looking for. Scrolling down to this last part that I want to cover is we will be using Llama Index for this workshop, but I just wanted to share a few ways that you can query using Weaviate, using the hybrid search, vector search, or BM25, but Llama Index also has great query interfaces. And they also have, or query engines, sorry, like the self-ask, the router, chain of thought, and many others. So I'd recommend using that, and I believe we'll be covering that in the next portion, which right now I'll hand it off to Aman.
Awesome, thanks, Erica. Cool, so I'm gonna go ahead and share my screen. And basically, we're gonna be picking up from where Erica just left off. Just a sec. So I can get my tabs together. Cool. Great. So let's say that you've initialized and set up your Weaviate client. What I'm going to be doing is basically walking us through how to evaluate the results that you get from either re-ranking or different chunking strategies directly in your notebook using our open source Phoenix tool. By the way, thanks for all of the questions and the Q&A. We'll try our best to sort of answer them as this presentation goes on, and maybe take a few at the end as well. So once you've kind of initialized your Weaviate client, I can then basically pull the data from that vector store into this notebook, as well as what we've kind of done is basically taken our pre-chunked data from Unstructured and stored it in this sort of in this bucket, which we can then kind of pull down from as well locally. I've basically run these 2 cells and a few of these cells to just sort of to basically kind of pre-run them a little bit, make sure that they're not going to take too long during this demo. And then again, just sort of asking a few questions related to Arize using our query engine, which was Llama Index underneath the hood. So things like, how do I get an API key? In this case, this is sort of imagine that this is kind of directly from that from the chunks that we've already stored, basically being used to augment the response from the LLM. Once we've loaded our chunks and our queries and responses into this local environment, we'll want to then load that data into a pandas data frame for us to basically use for the data analysis step. So one thing we'll do is basically read in those kind of preset, kind of pre-asked questions and knowledge base examples into this data frame, along with their corresponding document IDs. So the reason that you want to basically load in those document IDs that are related to each of the prompts is so that you can basically visualize the relationship from each prompt to its corresponding documents that are retrieved. And you can see that here. So as I was kind of alluding to earlier, when you're evaluating these types of systems, there's a number of things that can kind of go wrong, including grabbing points that are similar, but maybe not relevant. So one thing we did to kind of augment our sort of evaluation was to basically ask a sort of evaluation template question. So you can see here, we basically loaded in a sort of template evaluation, which is given the context string, which is the chunk that we've retrieved from the retrieval step, basically asking a LLM, in this case, it was a GPT 3.5 system, given the context information and no prior knowledge, answer this question, and then we loaded in the query string here. So you can see here, I basically have my models, my eval model, as well as the documents that I've retrieved, and asked GPT 3.5 using that query string, is the corresponding document that we've retrieved relevant to the question that the user is asking? And then I've loaded in that relevant score here as either a true or a false. And here's a small sample of that data frame. We basically did that for every document that was retrieved from for each question that the user asked. From there, we can basically use a kind of standard data science approach of using ranking metrics. So imagine in this case, instead of just using the relevance, we can also load in the sort of precision of that data. So here's an example of what that looks like. This data frame basically contains the text vector, the context, the similarity score, and as well as the relevance score. And from that relevance, you can actually grade either a sort of precision at 1 or precision at 2. So that's one of the metrics we're going to be taking a look at is the second document that we retrieved actually relevant or irrelevant to the question the user is asking. Great, so that's basically this data frame here, basically corresponding with the relevant scores of each piece of context, each document, and the precision of the retrieved document. You can take all that information and load it into a data frame here of basically the retrieved documents, the queries, and format it in a sort of standard way, which we'll basically link in the docs as well, to load that into a Phoenix schema, which is fairly straightforward. It's basically just the document IDs for each prompt or each query, as well as the prompt, what we're calling prompt or query here, the vector of those prompts, and the raw data so that you can visualize that in the platform. And then we've also loaded in the database as a whole, so the knowledge base. I've run that here, and if I open that up, so this is all running locally. So this is all in your notebook server. So Phoenix is fully open source, runs in your notebook. And I can see here that I've loaded a number of dimensions. So those same sort of variables I just described earlier, document similarity, as well as OpenAI precision and relevance of the documents and the user feedback. You can see here I have an embedding called a prompt embedding that I'm going to load up. While this is loading up, you can see that we also have a time series view at the top. If your data happens to be time series, if you'd like to see how it changes over time, you can load in that column as well and see how that changes. And here, this is a sort of 3D UMAP representation of our high dimensional embedding space of prompts and corresponding knowledge base, basically loaded into your notebook environment. I can go in and basically grab a cluster of points here, take a look at what they represent. So it looks like this cluster that we've clustered about based on the semantic similarity of these embeddings is questions like, I sent 8,000 records, but I only see 1,000 in the UI, why is that? Or how can I, basically questions that a user might ask of a chatbot. And you can see that most of these questions actually have to do about data or about how to ingest data. If I grab another sort of a cluster of points, you can see that these questions have to do with monitors. How do I have the ability to resolve a monitor? How do I unsubscribe from a monitor? So you can see that Arize Phoenix allows you to cluster about your data, your unstructured embedding data, to help you find patterns in that data. One thing we might want to do is actually use one of our scores to basically find areas to improve on in our data. So if I use the user feedback, I can grab the points and sort by lowest metric value first, to sort of see where are areas where my user feedback is lowest. You can see that there's a cluster of points here that has a user feedback of -1. And it looks like these questions are primarily have to do with the price of the Arize product. So what is the cost of the Arize product? Do you have a pricing calculator? What's interesting is if I open up these questions, I can basically see that the OpenAI relevance 0 and 1 is irrelevant. And if I take a look at the documents here, it looks like the documents that we've pulled in are actually kind of correspond with that. So if this question is about what is the price per volume, price per model, the sort of retrieved documents actually have very little to do with the questions that the user is asking. That's because the pricing information is actually on our marketing website and not on our technical documents. But let's say I don't have that user feedback and I still want to evaluate a system, a RAG-based system using the relevance score that we've loaded in. I can also use an OpenAI precision at 2 average, basically to kind of perform a similar calculation of using that pre-computed precision of the retrieved documents and sort the clusters based on that metric as well. What's interesting is if you use simply the cosine similarity of the document, so let's say document similarity 1, you'll find that actually the documents that are in this pricing cluster that have a very low precision actually have pretty high similarity scores and actually a range of similarity scores. What's interesting is that that sort of corresponds with our initial thought that, similarity may not mean relevance. And so what are some of the ways that you can improve on the system? You could try iterating on different document loading and chunking strategies, just as Ronnie described using Unstructured. So actually trying different chunking strategies and seeing if that improves your retrieval. Or as Erica described using Weaviate, you could use a re-ranking module in your vector database to basically try to pull a more relevant document at time of inference than the ones that's initially retrieved just using cosine similarity. Great, so that's a little bit about how Arize and Phoenix work with your data in your notebook to help you evaluate how to pull together, which documents are most relevant to the questions that your user is asking. It's fairly straightforward, just using a data frame, using objects that are already in your notebook, load it up, and all of this is open source and hosted directly in your own environment. None of the data is shared outwards. So if you need a tool to debug your RAG-based systems and try different approaches and evaluate the impact of those different approaches, feel free to take a look at the notebook. Let us know if you have any questions in the support channel, and we'll take a couple minutes to sort of answer any questions that might still be open. Cool.
Such a cool interface. I love the visualization aspect of it.
Yeah, and I really love that, once you load in the re-rank data, you can basically view the various different pieces of prompt. And this is something I should have noted as well, is that if you hover over each point, you can basically see what are the retrieved pieces of context to that point. So within the knowledge base, you can actually see how far away is each corresponding piece of context, so the prompt that the user might be asking.
It's really cool, the chunking techniques, but then also re-ranking to really improve the relevance of how well your LLM is doing. RAGs.
Cool. Okay, so I'm going to pick off one question here. One problem I see consistently with LLM-based evals is that, as was noted, relevant is not right. So there are lots of false positive evals. I saying this got the right chunk, but really got it wrong, get similar one. I'm wondering if any of you have explored other techniques for evals that might help mitigate this issue. That's a great question, Matt. So we kind of used relevance here as the metric because that's sort of intuitively what what's important at the query level. But you can imagine if you have a larger data set, or if you wanted to try a different metric, you could use a similar eval-based approach, or maybe multiple evals with different types of metrics there. So instead of relevance, maybe you want to say, likelihood that the question was correct, or that the context was correct. Or perhaps if you have a larger data set or a more specific data set, you could say, is the context, maybe if you're a healthcare company, you could say, is this context healthcare related or related to the system that the LLM is architected for or not? So you can build, kind of your own evals as well on top of your data set that what we're happy to cover in a future webinar. But great question that, if you could use a combination of different evals to answer that question. Great. And then Amir Siddiqui asked, can you explain how you're fetching the OpenAI precision score? So this is actually a request that we sent to the GPT-based model to compute relevance. And that is what defines the precision at 2, which is basically the number of top 2 retrieved documents that are relevant divided by 2. But if you have n number of documents, precision at n would be n. Are we able to color points in the Arize visualization based on a Weaviate property value, such as documentation chunks colored by red for Weaviate, blue for Unstructured, and green for Arize? Certainly possible to do that. Very interesting question. We didn't think of that one before. But you can basically color by any dimension that is in your data set. So anything that you may have loaded in already, you can actually color by that as well in the Phoenix interface. So we're flexible if you wanted to assign a tag or property to each of those kind of examples you just provided, that will be offered in Phoenix as well. So we're fully flexible in that colorization. Cool. Can you support metrics tied to some outcome, for example, like average awards at K? Absolutely. So kind of related to the previous question, if you actually have those metrics loaded in your data frame or computed at the data frame level, you can simply assign them in the data frame and basically assign them to the Phoenix schema as a column, and you'd be able to colorize based on that custom metric that you've defined as well. So good question. We are fully flexible for that as well. Great. Answering a few of these. Good question for Weaviate. Erica, do you want to take this latest one? How can you balance the cost benefit of re-ranking? Any best practices for this?
Oh, interesting. I guess because that requires another API call, there's obviously the trade-off of cost, especially considering how many requests you make. I don't know, I always rely on, it depends on your application. But if you aren't happy with the results from either pure vector search, or maybe you've also tried hybrid, I think instinctively the next step is to try re-ranking to improve the relevance and the output from your search. I hope that answers.
Eric, I have a question for you. Would you recommend re-ranking at every request or re-ranking a subset of requests?
Probably a subset, right? Because you don't want to run out of the API key. I think it's fairly cheap-ish, but at scale, it can probably get extremely expensive. So proceed with caution anytime you have a debit card or credit card behind an API key.
Awesome. Ronnie, there is a question for you here. What alternative chunking strategies are there other than HTML context aware, meaning strategies for unstructured text?
Yeah, things like when it comes to chunking strategies, I think definitely there are more techniques out there. If you look at LangChain and LlamaIndex, they implement like a different kind of chunking strategies. I think the one that I saw is they have the parent documents and child documents, like so you can actually break it down into smaller and more targeted text when you do chunking. But I think there are so many other things to do though. And like I think with LlamaIndex, they also do like a breaking down into different nodes. And when you do the queries, they can actually pulling the previous and the after like the nodes itself. So adding more context into your chunking. So if you're using unstructured, like the outputs from unstructured partition is JSON elements, which include the text and metadata. So like it doesn't limit only the HTML page. So if you're extracting data from your PDF or from your image, like so we have like a standard JSON output, and you can chunk anything like based on the different part of the elements. For example, it will identify like list items, tables, titles, etc. So you can do any kind of chunking. I hope I hope I answered the question, but let me know if there's any follow-up questions.
Yep. And if there's any follow-ups, we'll be hanging around in the community Slack as well to answer any questions there. So feel free to ask them if they come to mind later. Oh, there's one more actually, Ron, in here if you want to take. There can be multiple levels of metadata in the ingestion pipeline. For example, when ingesting PDF chunking by heading, the heading itself is a metadata. The name of the PDF is also a metadata. How to have this nested metadata ingested in VectorDB and use that for retrieval.
So yeah, I think again, back to my earlier answer. So like if we use unstructured, we extract the elements of the documents, and under the hood, unstructured partitions will identify which components, if this is a tables or is a titles or is a text, then this is something that automatically detect, and we kind of present it into the outputs in JSON format. So you not only you're getting the text itself, but you're kind of getting the element IDs and the metadata about the text itself.
Yeah, that makes a lot of sense. I'm gonna take some of these questions of, does re-ranking require a Cohere model, or can it be done with an open source equivalent model? Erica, I believe that there are other equivalent models as well, or equivalent approaches for re-ranking that are out there. Any thoughts on that one?
Yeah, so from a Weaviate perspective, if you are going to use our module ecosystem, we right now only have support for Cohere reranking, but also transformers. So we're constantly adding new modules to Weaviate. But I guess one other thing is we are open source. So if you find any other models that you'd like to contribute to Weaviate, that's a great way to make your first contribution. But I do believe there are other re-ranking models out there, just not implemented in Weaviate. I hope that answers it.
Cool. And then this one might be for the group. Should the chunking be used directly, or should the chunking be processed in some way before ingestion in the VectorDB?
I would say you'd want to chunk your data before uploading it to Weaviate, similar to how the flow was for this workshop, and going over the different strategies that Ronnie covered.
Mm-hmm. Yeah, agreed.
Yeah,
that should probably be part of the pipeline before you ingest the data. Cool. And then what have you found there to be the relationship between chunk size / overlap and chunking performance? I think I'll maybe take this one, Kelvin. So the answer is that your mileage may vary, and that's kind of what tools like Arize and Phoenix are around to help with, is that depending on your application, depending on what you're using the retrieval-based system for, you might find that different chunk sizes perform differently. So my recommendation is to try a chunk size that works for your application, maybe try to parameterize it or iterate through it, and then visualize the differences in results using sort of relevance or eval-based metrics, and load them in and evaluate, are you getting better or worse performance based on the different chunk sizes. Cool. If you have any more follow-up questions, feel free to drop them in the Slack. I did also want to plug that we are, Arize is also hosting an event in the New York City area. And Maggie, one of our people on the marketing team, will actually drop a link as well if you're interested in registering for that. Feel free to also follow that link for any upcoming events that might be interesting for you to help to kind of just learn more about what we're building in this ecosystem. But I wanted to thank Erica and Ronnie and everyone kind of behind the scenes also working on making sure that this was a sort of seamless learning experience for folks. And yeah, we'd love to work with you and partner with you again. So thanks for your time.
Yes, thank you. It was
Thanks,
wonderful.
everyone.
Cool. Thanks, everyone.